All right, guys, welcome back. Welcome to chapter 11. So, in our last chapter, we successfully got our ESP32 connected to a Wi-Fi network. Now, that was our huge big step in this third section of the book. And now we need to ask ourselves the next logical question. Once the device is online, how does it actually communicate to other devices to do something useful? So, in this chapter, we're going to cover fundamental networking concepts to make it all possible. Now, getting your device on the network is just the beginning. We now need to understand how the devices exchange data, perform something meaningful, and we'll explore principles that govern the devices to find each other, what languages they speak, and how they share information. Now, we're going to be talking about MQTT a little bit and a little bit about TCP/IP. And this is going to be how our modern systems and our IoT systems all communicate. So, the basic TCP/IP concept, well, this is definitely going to be the foundation for all modern networking. This is the internet itself. It's a set of rules and the protocol suite that we use, which we call TCP/IP. The best way to think about TCP/IP is as the global postal system for digital information. It provides information, standard addressing to all the devices on the internet, and all the rules of sending small packets between two devices on a network. The most the most fundamental concept in this is going to be the IP address, which we did in the last lab. Remember, we did an ifconfig. We're able to see that we've got an IP address. Now, remember, an IP address is just a unique numerical label assigned to every device on the network. It's like a unique phone number for your ESP32 or any other device. We also like to think of it like a street address of your house. It's a unique identifier that allows other devices to send data directly to it. Once you have an IP address, you'll have what we like to call a subnet mask. Working alongside the IP address itself is going to be the subnet mask. The subnet mask job is to tell the device which part of the IP address identifies the neighborhood or the local network it's on, and which part identifies the specific house or the device itself. This is critical because it helps the device quickly determine if another device is on the same network or if it needs to send the data out to a different network. So, what happens if the device needs to send to another network? It sends to the default gateway. The gateway is an IP address of a specific device on the local network, usually your Wi Fi router. Now, this acts as the exit door to the wider internet. All traffic designated for a remote network goes through the gateway. Now, the great news is after we connect our ESP to Wi Fi, you can get all three of these essential pieces of information: IP address, the subnet mask, the gateway by calling the single method of ifconfig. This will give you everything you need to know about your device's new network identity. Now, now that we're on the network itself, we need a language to communicate. The most common language on the web is going to be HTTP, otherwise known as Hypertext Transfer Protocol, and HTTP works on what we like to call the client server model. A client, like your ESP32, is a device that makes a request. The server is the device that hosts the information in response to that request. Now, HTTP is incredibly relevant to our automation projects like IoT because we can use it to have our ESP access online services known as APIs. Now, these APIs could be helpful for, like, maybe we want to fetch data like weather forecasts, or we can send it our own data like sensor readings to a web server for logging into, well, maybe take that logging data and send it and display it on a dashboard, someone to monitor that sensor data. Finally, we can even run a small web server on the ESP32 itself, allowing us to send it HTTP requests to control maybe an LED or a motor. Now, there are two types of HTTP requests. The first is the GET request. A GET request is used to retrieve data from a server. It is considered a read-only operation, and the analogy here is simple. You are asking a question or looking up a piece of information. The second type of request is going to be the post request. A post request is used to submit data to a server to be processed. This usually results in a change on the server, like creating a new entry in a database. The analogy here is submitting a form on a web page, or even uploading a file. Now, while HTTP is very common, it's not always the best tool for the job, especially when it comes to IoT. When you need to send frequently small updates, and maybe you're on an unreliable network, there's going to be another tool we can use. And the one that we're going to practice for this class is called MQTT. Now, what is MQTT? Well, MQTT stands for Message Queuing Telemetry Transport. Now, it is a messaging protocol that's designed from the ground up to talk machine to machine and IoT communication. It is extremely lightweight, which makes it perfect for small resource-constrained devices like our ESP32. Now, MQTT works very differently from HTTP. It's a central hub called a broker and a communication pattern known as publish or subscribe. It's very powerful because it completely separates and decouples the device sending a message from the device receiving it. The first component I want to talk about is going to be the broker. The broker is the central server that manages the flow of all messages. Every device or client connects to the central broker, and they don't connect to each other, just to the broker. The next component is the client. A client is any device that's connected to the broker. This could be your ESP32, a computer, or any other smart device. A client can act as a sender of messages, a receiver of messages, or even both. So how does a broker know where to send messages? Well, it uses what we call topics. A topic is simply a text string, often structured like a file path, that acts like a label or category for the message. For example, a temperature sensor in a specific room might send its information to sensors, room 101, temperature. Now, the broker is going to then receive this information and then use that for anyone who wants to subscribe. So the two actions of MQTT, a client that sends the message to the broker is called a publisher. A client that tells the broker that it's interested in receiving messages on a specific topic is called a subscriber. The broker's job is to take every message published on a topic and forward it to the clients that have subscribed to this topic. This is where I like to say that MQTT is like Reddit. You have topics that you post to, and there are people who want to subscribe to said topics and actually read those topics and maybe even reply to those topics. The most powerful benefit of the publish subscription model is that all the devices are decoupled. A device publishing a temperature doesn't need to know if there's any devices listening. And the device that subscribes to the temperature readings doesn't need to know which sensor is actually sending the data. They are completely independent and only communicate through the broker through a shared topic structure. All right, today's class is going to be the perfect demonstration of this topic. For those that are in class, you're going to be setting up two ESP32s. The first will be the publisher, and it will publish a message every time a button is pressed. The second ESP is a subscriber. It will subscribe to the same topic, and it will in turn turn its parent LED on or off. Now, this is going to create a fundamental device-device control system, which is something that we do a lot in the IoT systems. If you're an online student, you may be using the same ESP32 to turn on and off the LED, but you'll still be using your MQTT to send that communication. All right, to wrap up, you now have a solid understanding of the fundamental process that allows our devices to communicate. You've learned the basics of TCP/IP, addressing, and make sure that we understand that this is how we get our unique identities. You're going to understand that we use a client server model when it comes to HTTP, and we've learned that we now can use MQTT, which is a lightweight, high efficient publish subscribe model. These protocols are essential building blocks for the future projects that we're going to be doing. And it's definitely something that if you want to use automation in your network, something I highly recommend that you read more into. I'll see you for chapter 12.